a look at another example of using Table G, questions that you are going to have to answer. So in this type of question, you will be given the XY coordinate, and based on where that data point falls in reference to the solutes curve, will it be a saturated solution, unsaturated solution, or a supersaturated solution? So when I take a look here, my XY coordinate, I have 106 grams at 60 degrees Celsius. So my XY coordinate is 60 degrees Celsius, 106 grams. So I need to make a data point on this table. So I have 60 degrees Celsius going up here and around 106 grams. So here is my XY coordinate. Okay, so I'm going to take a look here. So I have the solute NaNO3. So here is NaNO3's curve. So I'm just going to highlight it in yellow. Right? This data point is below NaNO3's curve. So the data point is below the curve. So if the data point is below the solute's curve, then we say that it is unsaturated. Our next solute is KNO3. So here is KNO3, and here is its curve, if I can trace it. And that data point is on KNO3's curve. So for KNO3, this XY coordinate would make a saturated solution. And my next example is KCl. So I see KCl, and here is KCl's curve. This data point is above KCl's curve. And if the data point is above the curve, then we would describe it as a supersaturated solution. Okay, so let's take a look at using the graph to figure out some other processes. So my next problem here is a solution contains 70 grams of KNO3, and it's being held at 50 degrees Celsius. So I'm given information XY coordinate. So my X is 50 and my Y is 70. So I'm going to go make that data point. So where 50 degrees Celsius meets 70. So this is the data point I'm looking at right now. Okay, so when I take a look at this data point, that black data point in reference to KNO3's curve, so here's KNO3's curve, that data point is below the curve. Okay, so it's below KNO3's curve, so this is an unsaturated solution. So this is where I'm starting. So this solution is unsaturated at this point in time. But what I want to end up with is a saturated solution. So that's my end point. So my end point is I need it to be saturated, so I need to be on the curve. What this question is telling me is that I can manipulate the temperature of this solution. Temperatures are on the x-axis, so I am going to manipulate the information on the x-axis, and when I manipulate it, that means I'm going to move the data point either to the left or to the right. So this data point, to make it go on the curve by manipulating the temperature, I'm going to move it to the left. So that means I'm starting at a temperature of 50 and I'm moving it to a temperature that is close to 40. It's not quite 40. I overshot the arrow there, but the curve, where I hit the curve, it's just past the 40. So that means my manipulation, if I have to describe it, is I'm going to decrease the temperature to about 42 degrees Celsius. And if I drop the solution's temperature about 42 degrees Celsius, then I am going to have a saturated solution. When I take a look at the next question, okay, I have the same XY coordinate. I still have a Y coordinate of 70, X coordinate of 50, so it's the same data point. I'm working with the same solute, KNO3, okay? So that data point in reference to KNO3, where we're starting, the data point starts, right? It is still below the curve, and so I still have an unsaturated solution, but with some sort of manipulation, I need to have a saturated solution, which means I have to end up on the curve. So where this problem has to end, I need to be on the curve, so it is saturated. But in this question, what I'm allowed to manipulate is the mass. The mass is the y-axis information, and the y-axis runs up and down. So I take a look at my data point, and for it to hit the curve, I need to make it move up in this second scenario. So I start off with 70 grams, right? I need to have a total, it looks like it's about halfway, maybe 85 grams. So that means, ultimately, to make this happen, is I have to add around 15 grams of KNO3. Temperature stays at 50, I just have to add some more solute. So with that being